This video is brought to you by Surfshark. Safety and security online are critically important, and you can protect yourself online with Surfshark. Get 83% off and 3 months for free through the link in the description below. Far away from Earth, in the constellation of Sagittarius, so far it takes like 27,000 years to reach it, lurks a star-devouring monster. Located at the very heart of the Milky Way, this monster measures some 44 million kilometers in diameter, with a mass equivalent to over 4.3 million suns. It accounts for 99.9% of all mass found at the center of our galaxy. Yet this creature isn't some fictional Lovecraftian elder god slumbering on the edge of space. No, it's deadly real, a product of physics, even if the laws of physics themselves break down at its center. Known as Sagittarius A star, it's our local supermassive black hole. For most of human history, the existence of this galactic scale of Earth was a mystery, as alien to our ancestors as gravitational waves or the Higgs boson. It was only in the 1930s, when we began detecting strange radio signals from the heart of our galaxy, that we realized something utterly fascinating was lurking out there, something we're still battling to understand to this very day. It was at the height of summer 1931 when Karl G. Jansky made his eerie discovery. A radio engineer of Czech-French descent, Jansky had been hired by Bell Telephone Laboratories in New Jersey to locate sources of static that might mess up their communication systems. To do this, he'd built what is considered to be the world's first radio telescope, a strange-looking array of antennae and wheels that must have seemed like science fiction to his contemporaries. But when Jansky began using it to hunt for sources of static, he stumbled upon something truly remarkable. Way up in the sky, a strong radio signal was emanating from the heart of the Milky Way, specifically from the constellation of Sagittarius. Jansky had no way of knowing it, but he'd just become the first human being in history to detect a signal related to our galaxy's supermassive black hole. These days, of course, we have a much greater understanding of Sagittarius A star. We know, for example, how heavy it is, with a mass equivalent to 4.3 million suns. We know, too, how large an area it covers, with a radius of 22 million kilometers. You could swap our sun for Sagittarius A star, and its outer edge would almost reach Mercury. Yet, for all we think we understand this behemoth, there's still a lot about it that boggles the mind. For instance, we've known for years that our supermassive black hole flashes irregularly, sending out seemingly random bursts of bright radiation, the only known black hole to behave this way. Weirder still, we know also that it's leaking. At the beginning of 2022, NASA announced that Sagittarius A star had been discovered to be emitting superheated material for thousands of years, likely the afterproduct of a star or gas cloud devoured long ago. Yet, despite all of this seemingly intense activity, Sagittarius A star is also notable for something else, and that's how unusually quiet it is. Although it might be a colossal radiation-emitting titan from our perspective, compared to other supermassive black holes, it is more like a fat, contented cat napping peacefully in a sunbeam. According to Scientific American, this is because Sagittarius A star is in a dormant phase, like a post-lasagna Garfield. Were it in the active, quick-eat-everything-before-John-gets-home phase, the radio signal Jansky detected back in 1931 could have been up to 1 billion times more powerful. Yet this doesn't mean our local supermassive black hole is always slumbering. In the not-so-distant past, it may have been terrifyingly active. One of the slightly gross things about supermassive black holes is they, like Barney Gumble after too much duff, often burp. But while Barney belching is only gross if you spend too much time in Moe's Tavern, the supermassive black hole equivalent is utterly cataclysmic. As more and more material falls into the monster's maw, the magnetic and gravitational forces superheat the surrounding gases to millions of degrees. Things eventually get so intense that some of the gas gets ejected out as an enormous jet of high-energy particles, blasting tens of thousands of light-years into space. Loaded with X-ray and ultraviolet radiation, these burps can devastate anything in their path. One recent study has shown that were Sagittarius A star to burp on Earth, it would strip our atmosphere away. Fortunately, we're too far away for that to happen. Our planet would have to be 10 times closer to be at risk of these killer belches. But we can still see traces of past events. Expanding out of the top and bottom of our galactic disk are two enormous blobs of hot gas, each one weighing millions of times more than our Sun. Known as Fermi Bubbles, the largest one extends 23,000 light-years upwards into space. Estimated to be 6 million years old, they're evidence of a recent-ish time when Sagittarius A gorged itself like crazy. Yet while this particular feast happened millions of years ago, there's evidence that most supermassive black holes have far shorter cycles, perhaps leaving as little as 100,000 years between feeding frenzies. If this seems wild, though, you should probably prepare yourself. To understand the story of Sagittarius A star, we first need to try and wrap our head around what supermassive black holes really are. And believe me, things are going to get pretty weird. When confronted with the fact of a gigantic black hole squatting at the heart of our galaxy, the logical question seems to be, well, how did it get there? What's so special about the Milky Way that it gets its own monster? The answer is nothing. There's nothing special about it at all. In fact, it seems that almost every galaxy above a certain size has its own massive black hole. Like Sagittarius A star, these other giants sit at the very center of their galaxies. Unlike Sagittarius A star, though, they can be seriously supermassive. As far as we can tell, the size of a supermassive black hole is inextricably linked with the size of its host galaxy. The more mass the galaxy has, the bigger the black hole. Now, with such a clear correlation, it might be tempting to think that these behemoths are somehow responsible for galactic formation, that without them, the structure of the universe would be completely different. Except there's no hard evidence that this is the case, just as there's no hard evidence that large galaxies inevitably create supermassive black holes. The snappily named A2261 BCG, for example, is a galaxy of absolutely gargantuan proportions, 10 times larger than the Milky Way, yet it seems to be missing a central black hole. Still, the vast majority of large galaxies do appear to have them, and many are far, far more active than Sagittarius A. Quasars are ancient supermassive black holes that are so active they've basically ignited the entire core of their galaxy. We've so far identified more than 100,000 of them, each powered by a black hole feeding frenzy that's beyond anything our galaxy has ever seen. And speaking of power, if there's one thing these monsters are capable of, it's energy production. You've probably heard of the concept of an event horizon, the boundary around a black hole from where the gravitational pull gets so great that not even light can escape. But just before you cross that horizon, things get seriously energetic. When a supermassive black hole is spinning, it can pull in material around it into a superheated disk known as an accretion disk. It's from the incredible temperatures in this disk that the insanely bright signals blasting out from quasars come from, lighting up the night sky more ferociously than millions of stars, and perhaps no wonder. Black holes are thought to transform mass into energy with a 40% efficiency, which is way beyond even what a nuclear reaction is capable of. As black hole researcher Marta Volonteri put it to the BBC in 2021, black holes are the most effective, energy-efficient engines in the universe. It's this massive energy conversion that allows us to see an object that, by definition, doesn't reflect any light. Remember that incredible photo from 2019 showing the first ever image of a black hole? Well, that was only possible thanks to the accretion disk swirling brightly around it, allowing the creature at the center of Messier 84 to cast a visible shadow. But taking that photo was a time-consuming process involving the use of a global network of radio telescopes. When we want to take a peek at a supermassive black hole, there are far easier ways. One method is to forget about the accretion disk and instead focus on the stars closely orbiting it. This is what we do when we want to look at Sagittarius A star, using the orbits of stars like S2 to calculate the forces at work. From there, we can draw a pretty good idea of what the black hole itself must be like. Another, way more sci-fi method is using gravitational waves. Only detected for the first time in 2015, gravitational waves are ripples in the fabric of space-time flowing out at the speed of light from mergers between incredibly dense objects. Although we can't pretend to understand the theory here, actual expert Professor Paolo Pani told the EU Horizon program in 2019 that they could be used to view black holes. As a report on his interview summed it up, by studying the features of these waves, it is possible to obtain information about the mass, rotation, radius, and speed of these previously invisible objects. Again, look, we're YouTubers, we're not cosmologists, we can't pretend to wrap our small brains around this, but we do know that it's great news. The more we learn about objects like Sagittarius A star, the more we understand the universe itself. And that is no exaggeration. Because aside from being weird as, supermassive black holes represent a tantalizing mystery. We currently have no idea how they got so massive in the first place. Now, just before we continue with the rest of today's video, let me tell you about today's wonderful sponsor, Surfshark. Do you use the internet? Of course you do. You're on the internet right now. Do you have personal information that you'd rather remain personal? Of course you do. Who doesn't? Well, let me tell you something. The internet is a weird place. There are people out there, they want to ruin your day, or your week, or even your month. They want to steal your details, steal your identity. Unfortunately, that's a thing, and it can be a real pain in the arse. Well, Surfshark has Hacklock. This searches databases for your passwords, which sounds bad, but don't worry. If they find your password, they'll let you know. You change that password and boom, safe again. Also, Netflix is fantastic for opening up your streaming options. For example, say you live in Europe and you're like, oh my god, Netflix America has loads of stuff, but I don't live in America. Well, fire up Surfshark, hop on over to Miami or wherever you like, and you'll find that you get a whole lot more streaming options. And that applies the other way around as well. Europe, different to America. Asia, I'm sure even more different as well. Surfshark's also totally unlimited, so you can watch, download as much as you like. No worries. Go to surfshark.deals/geographics. You're at 83% off and 3 extra months for free. And now back to today's video. You've watched enough TV. You know how a black hole forms. A star above a certain size goes supernova, leaving the core to collapse in on itself and become so dense that not even light can escape its pull. Now, that's all true, but it presents a problem. There's no way that a regular black hole formed from a collapsing star could ever grow as big as Sagittarius A star. That's not to say they can't grow. As they devour more matter, they absolutely do. But the rate of growth is so slow that even if you assume a really big star once existed that collapsed into a black hole just 200 million years after the universe was born, you still wouldn't have enough time for it to grow to the supermassive size that it has today. And that's when you've got 13.5 billion years to play with. But we already know the first supermassive black holes appeared long before that. Those quasars we mentioned? Well, because they burn so bright, many of them are visible to us from the very edge of the visible universe. That means we're seeing them from almost the dawn of time, around 600 million years after the Big Bang. To use a slightly goofy analogy, finding black holes with masses millions of times that of our sun so close to the dawn of time and assuming they just grew from regular black holes is like finding an elephant in a crash and just assuming that it's a deformed child that had a sudden growth spurt. They're clearly different beasts. So where did Sagittarius A star and all of its overgrown brethren come from? One popular theory suggests they grew from seeds. The idea goes that maybe there existed a size class of black hole that's way bigger than regular, but way smaller than these galactic monsters. Created from collapsing dust clouds at the dawn of the universe, these welterweight black holes formed when the universe was so cramped that they had endless matter to gorge on, and since they were already on the big side to begin with, it took them less time to consume things and become supermassive. This is the most likely explanation, but it's also one that runs into problems. One is that there's no certainty early giant gas clouds would have collapsed so spectacularly. The other is that even with this head start, it's not certain the laws of physics would allow the seed black holes to grow so big so fast. Another possibility is collision theory. Nearly all large galaxies with their own Sagittarius A star show evidence of having collided with another galaxy at some point. This has previously happened to the Milky Way, and it's destined to happen again when our galaxy goes leaping into Andromeda's big manly arms in about 4.5 billion years. Given these constant collisions, it's possible that today's supermassive black holes are the result of billions of years of black hole mergers. Again though, this idea runs into problems. Although most galaxies show signs of having been in collisions, not all of them do. There are a handful of galaxies out there that have seemingly never crashed into a neighbor. Annoyingly, they also seem to have supermassive black holes at their center, effectively killing this theory. That leaves only options that take us way outside of our comfort zones. The first two involve something that everyone has heard about, but has never been detected: dark matter. In a nutshell, dark matter is a theorized particle that is thought to make up 27% of all mass in the universe. It may also be where supermassive black holes come from. According to one theory, Sagittarius A star and others may have formed from dark matter itself. According to an even wilder theory, Sagittarius A star may, in fact, be dark matter. This one comes from a study published in spring of 2021. In it, the researchers argue there's no black hole in our galaxy's center, massive or otherwise. Instead, there are clumps of dark matter that are so vast they mimic the effects of a black hole while being just weak enough to allow clouds of gas to pass by undisturbed, something that has been documented happening around Sagittarius A star. The final far-out theory involves primordial black holes. These are hypothetical black holes that were created at the birth of the universe, and they could have been formed already at a gargantuan size before the first stars ever appeared. As with dark matter, though, their purely theoretical nature makes actually testing this theory pretty much impossible, putting it firmly into the wild speculation zone. Alright, so that's what we sort of do and mostly don't know about supermassive black holes, and it naturally leads to another fascinating question. How did we discover so much about them in the first place? It was just before Christmas 1915 when Albert Einstein received an unexpected gift. About a month earlier, the great scientist had published his paper, The Field Equations of Gravitation, laying out further the relationship between matter and space-time. As well as publishing, Einstein had also sent a copy to his friend, the German physicist Karl Schwarzschild, who was then fighting on the front lines of World War I. But rather than be all like, "Cool paper, bro," Schwarzschild had taken time out from the miserable grind of life in the trenches to write back with a solution. It was a solution that suggested how a star could theoretically exist of such high density that not even light itself could escape its pull. In other words, the first description of a black hole. Originally called frozen stars, they were for a long time only a mathematical curiosity, a weird anomaly that couldn't possibly exist in real life. Indeed, Einstein himself argued in 1939 that they were impossible. By then, Schwarzschild was long dead, having died from disease way back in 1916. Yet it would be Schwarzschild who history eventually proved right. The revelation that black holes were terrifyingly real came in slowly, effectively in parallel with our discovery of their supermassive cousins. By the time Einstein was dismissing the idea in the late 30s, Karl Jansky had already detected the first signals coming from Sagittarius A star. Not that anyone was desperate to find out what it was. Since Jansky's discovery had no connection to communications, his employers refused to fund his study further. And so, investigation into what Jansky called star noise would be put on hold for decades. Critically though, humanity would return to it at around the same time that we finally began to discover the first regular black holes. The 1960s were an exciting time for astrophysicists. In 1964, a bright source of X-rays known as CYG-X1 was found in the night sky, eventually found to be the first known black hole. Around the same time, scientists were making massive strides towards uncovering their supermassive counterparts. The early 1960s saw the discovery of quasars, what we now know to be extremely ancient, extremely large black holes igniting the cores of far-distant galaxies. Likewise, interest was growing in what had come to be known as radio galaxies. Galaxies emitting strong radio sources, they had long puzzled scientists, especially because the signals seemed not to be coming from the galaxies themselves, but from giant lobes projecting above and below the galactic disk. Today we know this is the result of a supermassive black hole belching out of two ends at once, like that gross kid in elementary school who's mastered simultaneous burping and flatulence. Back then, though, these radio lobes were a mystery, until scientists in the 1960s discovered the thin jets leading from these bubbles back to the galactic center. As they looked into it more and more, they started to realize that the source of these jets must be tiny, smaller than a single solar system, yet containing millions or billions of solar masses. Before long, it was clear only one theorized object was capable of being so dense, a black hole of incredible proportions. And this raised an interesting question. If other galaxies house gigantic black holes, what about our one? It wouldn't take long for people to start looking. The The first indication we had of the star-swallowing monster at the heart of our galaxy came in 1974 in a paper by Bruce Ballack and Robert L. Brown. The pair had discovered a seriously powerful radio source, initially given the incredibly unsexy name Galactic Center Compact Radio Source. In 1982, though, Brown decided to rechristen his discovery. In atomic physics, putting a little asterisk next to a name indicates it's in a high-energy state. Brown evidently thought this was pretty neat because he decided to use it for his own high-energy discovery. Taking the name of the constellation it appeared in, he called this mysterious radio source Sagittarius A*, or Sagittarius A star. Now, all humanity needed to do was prove it was a black hole. As we're about to see, this was easier said than done. Even though the odds were that Sagittarius A star was an enormous black hole, scientists couldn't actually prove it was anything more than a weird bright object. To actually figure out what it was, they'd need to overcome some incredible technological hurdles. Hurdles that prevented us from seeing into the core of our own galaxy. Luckily, leaping majestically over technological hurdles is what science is really all about. The breakthrough was the creation of high-resolution infrared cameras. Prior to this, the biggest issue had been that we can't actually see the center of our galaxy with even the most powerful telescopes. There's just too much interstellar dust in the way. So much so that it absorbs 100% of the light emitted on the visible spectrum. Infrared light, though, leaks through. Not much, just 10% of what those stars clustered around Sagittarius A star give off. For these awesome new cameras, though, 10% was enough. Enough to start tracking and making measurements of stars right near our galactic core. And what these measurements showed was something massive lurking within the constellation of Sagittarius. Starting in the early 2000s, scientists were able to follow the paths of stars like S2 as they whirled around this invisible object. Figuring out their orbits allowed us to figure out the gravitational pull of whatever they were orbiting. This meant we could calculate its mass, which gave us such an absurdly high number that the only possible answers were either A, a supermassive black hole, or B, your mum. Fast forward to 2020, and the Nobel Prize in Physics was jointly awarded to those scientists who helped prove Sagittarius A star must be a black hole. But just because we now know what lies at the heart of our galaxy doesn't mean the story is over. The more we learn about our resident supermassive black hole, the more interesting the future of science seems to become. Right now, for example, scientists at the Event Horizon Telescope, a project that links radio telescopes across the planet to effectively make one big-ass telescope, are finally trying to capture an image of Sagittarius A star. Nor are they the only ones. The James Webb Space Telescope will count among its missions and attempt to peer into the heart of our galaxy's core, potentially the best shot we have at understanding its unique properties. In short, this is a pretty exciting time to be a black hole scientist. And as we learn more about Sagittarius A star, we might uncover all manner of other things about our universe. For instance, just last year, Scientific American reported on research by Avi Loeb and Manasvi Lingam that suggests Sagittarius A star's dangerous belches may have hindered life's development on Earth, potentially wiping out any complex life forms for billions of years until our star at last moved far enough away. It's still an unproven theory, but it does show how much more we might discover as our understanding of the Leviathan in our galaxy grows. As we wrap up this video, then, we do so potentially on the brink of some incredible discoveries. From a weird signal detected by a guy working for the telephone company, Sagittarius A star has evolved into what we know it is today, a monster of a black hole spinning at the very heart of the Milky Way. And if our understanding can change so much in 90 years, who knows what breakthroughs the next century will bring. Because, make no mistake, there is a lot to learn about our local supermassive black hole. Stuff that makes even trained astrophysicists giddy to think about. If there's one thing we're sure of, it's that it's going to be exciting as heck watching them figure it out. Hope you found today's video interesting. If you did, please do hit that like button below. Don't forget to subscribe. And thank you for watching.